Walk through any building and you're surrounded by walls. But have you ever stopped to think about what each one is actually doing? Some are holding up the roof, some are bracing the building against hurricane-force winds, and others are just there to give you privacy. Confusing these types isn't just an academic error, it's one of the fastest ways to cause a structural disaster during a renovation. So, how do you tell them apart? In this video, we're breaking down the different types of walls you'll find in any construction project, moving far beyond this is a brick wall or this is a drywall. We'll explain the function, the hidden job that each wall is performing, which dictates its design, its materials, and what you can and cannot do to it. By then, you'll be able to look at a wall and understand its role in the building's ecosystem, making you a more knowledgeable builder, designer, or homeowner. Let's start with the most critical distinction, the one that can literally make or break a building: load-bearing versus non-load-bearing walls. This is the number one thing you must get right. A load-bearing wall is a primary structural element. It acts like a vertical beam. Its fundamental job is to transfer the dead weight of the roof and floors above it, along with live loads like people and furniture, down to the foundation. You can often identify them in plans because they align directly with structural elements like beams, columns, or trusses above. They are typically thicker and constructed from robust materials like reinforced concrete, load-bearing masonry brick or block, or structural timber frames. Removing or altering one without installing a proper engineered support, like a steel beam or reinforced concrete lintel, can lead to sagging floors, cracked walls throughout the structure, or even a partial collapse. The consequences are that severe. On the flip side, a non-load-bearing wall, also called a partition wall or curtain wall, carries no structural load other than its own weight. Its purpose is purely functional and architectural, to divide space, provide privacy, offer sound insulation, and provide surfaces for utilities like electrical outlets. They can be made from much lighter, more flexible materials like gypsum drywall, glass panels, or lightweight concrete blocks. A pro tip for any renovation, from a project manager with decades of site experience, is to always assume a wall is load-bearing until you can definitively prove otherwise with original structure, REL drawings, or a professional assessment. A common and catastrophic mistake is a homeowner or an inexperienced contractor knocking down a wall to create an open-plan space without understanding its critical structural role. Now, let's talk about a wall that is a silent guardian during storms and earthquakes, a wall that works tirelessly behind the scenes, the shear wall. Also known as a braced wall or a lateral force-resisting system. This is a specialized type of load-bearing wall, but its primary function is to resist lateral forces. Think of a tall building as a flexible ruler. When powerful wind pushes against it or an earthquake shakes the ground from side to side, the building wants to sway and rack out of shape. Shear walls are the rigid, vertical diaphragms that prevent this excessive swaying. They are essentially the building's backbone, transferring these destructive horizontal forces down to the foundation, where they can be safely dissipated. You'll typically find them as solid reinforced concrete walls or on elevator shafts, stairwells, and service cores, the places where you can't have many windows or doors. In wood-frame buildings, they are created by sheathing a wall frame with plywood or oriented strand board OSB and using specific, code-prescribed nailing patterns. The efficient workflow secret is that the location of shear walls is meticulously planned by the structural engineer to create a symmetrical and balanced resistance in all directions, preventing the building from twisting. Drilling unauthorized large holes for utilities or cutting into a shear wall to create a new opening can severely compromise a building's ability to withstand an earthquake, effectively removing a key part of its structural skeleton. While the previous walls are part of the building's skeleton, the exterior wall is its skin, its protective clothing, and its function is incredibly complex and multi-layered. Also known as the building envelope, its job is to create a stable, controlled interior environment by separating it from the highly variable and often harsh exterior. This is not a single function but a symphony of several critical roles performed simultaneously. It must be a weather barrier, resisting driving rain, snow, and wind from penetrating the interior. It must be a thermal barrier, containing continuous insulation to minimize heat transfer, keeping interior warmth in during winter and heat out during summer, which is fundamental for energy efficiency. It must be an air barrier, creating a continuous seal to prevent uncontrolled air leakage, which is a major source of energy loss and potential moisture problems. And it often needs to manage vapor diffusion to prevent condensation within the wall assembly itself, which can lead to hidden mold growth and structural rot. A common and costly drafting mistake is to focus only on the aesthetic cladding material brick, siding, stucco without meticulously detailing the critical hidden layers behind it, their barrier, waterproofing membrane, and thermal insulation, leading to chronic moisture problems, mold, and exorbitant energy bills for the building owner. For specific site and functional conditions, we have highly specialized walls. A retaining wall is designed for a single, massive purpose, to hold back soil and create a level difference between two elevations. It's an earth-retaining structure that resists the immense lateral pressure of the soil and water behind it. Its design is dominated by geotechnical engineering, considering factors like soil type, water table, and surcharge loads. They are found everywhere, from simple landscaping projects to the critical earthworks supporting highway overpasses and basement walls. Then there's the curtain wall, a defining feature of modern skyscrapers. This is a non-structural outer wall, typically made of a lightweight aluminum frame that is filled with large panels of glass or metal. The key point is that it hangs off the building's structural frame like a curtain, hence the name. It keeps the weather out but doesn't support the floor or roof loads, which are carried by the building's internal steel or concrete skeleton. This is what gives modern skyscrapers their characteristic all-glass, transparent appearance. Finally, we have walls often defined by their material composition, which directly relates to their function. Masonry walls, built from brick, concrete block, or stone, offer excellent compressive strength, fire resistance, thermal mass, the ability to absorb and slowly release heat, and a timeless aesthetic. A cavity wall is a specific type of masonry wall with a crucial innovation, a continuous air gap between two layers of masonry. This cavity acts as a primary drainage plane, allowing any water that penetrates the outer layer to drain harmlessly down and out through weep holes, effectively preventing moisture from reaching the inner leaf. Precast concrete walls are manufactured off-site in a controlled factory environment and then transported and lifted into place. This offers tremendous advantages in speed of construction, quality control, and a flawless finish, and they can be designed to be either load-bearing or simply cladding. To summarize the key takeaways: 1. Load-bearing walls carry vertical loads from the structure above. They are the pillars of the building, and removing them requires engineered solutions. 2. Shear walls are the hidden heroes that resist lateral forces like wind and earthquakes. Compromising them is a grave safety risk. 3. Exterior walls are complex, multi-layered environmental shields managing water, air, heat, and vapor. It's the performance of the entire system, not just the cladding, that matters. And 4. Always identify a wall's primary function before judging its form or material. Its purpose dictates everything about its construction. Now I want to hear from you. In the comments below, what's the most challenging wall detail you've ever had to design, build, or renovate around? Was it a complex shear wall connection in a seismic zone, a tricky exterior wall assembly in a rainy climate, or a scary moment discovering a load-bearing wall that was about to be mistakenly removed? Your field experience and war stories are invaluable for our entire community. If this guide to wall types and functions has built a stronger foundation for your knowledge, please give this video a like and subscribe to Smithage for more content that constructs your expertise on the ground up.